Okay, we'll get going here. Once again, welcome to Applied Day. This is the Design Automation with or Without the Cloud presentation. I'm joined by Jerry Oy and Corey Andersen, who you'll meet in just a moment here. Before we dive in, I just want to give a quick background of applied engineering. For over 35 years, Applied has been helping companies overcome their engineering challenges, whether that be with our technology team providing training, implementation, and support for software and hardware solutions, or our services team providing design and manufacturing engineering, as well as software development and reprographics. We fit your needs and your business. With that, I'll turn things over to our presenters.
Thank you, Emily. Welcome everyone to the webinar today. I am with Corey Andersen. He is our applications developer, and I myself am a application specialist. So I do training with some of the different flavors of the Autodesk software, specifically AutoCAD and Inventor. Do some of the classes as well as use the softwares for various engineering products. And then Corey is application developer, so any customers that come in and wants some sort of applications developed for their needs, then Corey and his team are kind of in charge of that. So the way this webinar is gonna go, I'm gonna do my best to kind of fly through some of these slides. I myself have roughly about 20 minutes worth of material to go over, specifically without the cloud. So I'll be going over a simple assembly file that has some iLogic rules created within the file to make the assembly, essentially a automated assembly, and think of it as a more intelligent assembly where you can bring up a dialog box, which is just called a form, and you can make various changes to that form, and then in turn you'll see your assembly update and whatever type of specific changes you made into that form, whether it's material type or change in size of particular components and what have you. And then once I get done with my portion of the iLogic without the cloud, then Corey will kind of go over how to automate your designs within the cloud, which is the utilization of Autodesk product called Forge. So some of you may have attended some of the webinars yesterday. You can see on the slide here what we had offered yesterday. And then immediately after this webinar, Alex Sinclair, he's one of our FEA gurus. He has a webinar from 10 to 11 essentially, applied advanced engineering and analysis. So if you have any time, I would recommend attending that one, along with some of the other ones you can see within this slide as well. So Emily already went over this slide as far as how we fit in your various needs. So getting into design automation, why would anybody want to use design automation? Well, there's many different areas, and these are just four of the more common ones to eliminate some of the more repetitive tasks that you might do within your piece part files or assembly files, reduction in the amount of errors that may come up within your designs. And then if you want to create any drawings or whatever, you can most definitely create your drawings more efficiently and effectively. And then empower sales team and or customers to maybe go onto the cloud. Think of maybe going to like if you ever go online to a automotive website where you want to build a car or something like that, you can pick your colors and pick your various options of the wheels and things of that nature. So that's kind of what Corey will kind of go over a little bit is going into Forge and being able to take a design and make it the way that you want it, as far as the different settings there. So as far as locally, you can automate your designs locally using a built-in portion of Inventor, in this case called iLogic. You do not need any programming expertise. It is beneficial if you do have it. You can create more in-depth, I guess, rules and things of that nature when you're in your Inventor iLogic rules. Inventor comes with what's called snippets. So it's a starting point for you to develop your various rules within your parts and assemblies. Some of the things that your rules can do is manipulate the parameters or the dimensions that are used within your designs, as well as the I properties, designed by, engineer approved by, description. You can very easily change a lot of different properties using the various iLogic rules. And then you also have a pretty straightforward way of creating a custom dialog box, or in this case called forms, to be able to change the different cells within your dialog box to adjust your assemblies or your part files. So I'll be getting into a demonstration then in this gripper assembly. So I want to be able to develop a form. So that form is on the left there, example of the form there, and I'll have a slider bar that will allow me to maybe decide how many holes, mounting holes I want on this base plate here, as well as what type of material do I want for that base plate. So there's a drop-down field here to adjust the material type. There's these gripper class here, the kind of the magenta color here, the aqua color. So I want to be able to maybe change the length of those grippers. And it's all kind of dependent on maybe what size of motor do I want to use. So again, there's another field within this form that would allow me to change the various size of motor I want to use in this gripper assembly. So in the middle area here is the actual rule editor. On the left section is what's called your various types of snippets. And with every version of Inventor that comes out, Autodesk keeps adding to all these various folders that have the various types of different snippets in it. So, oops, let's go back here a second here. So I'm going to get out of the slide here, and then I'll just dive right into an Inventor. So hopefully everybody can see Inventor here. Kind of on a side note, I'm using 2022 right now. So now the dark theme is now no longer in beta. It's full release. So I would recommend taking advantage of that. So this is that gripper assembly, and I want to be able to automate this assembly file. So I don't have to physically go into, let's say, my model tree and maybe do a replace component to replace this out with a different type of material, you know, that may also have a different quantity of mounting holes that go around there. And then, as I had mentioned, as far as changing the length of those gripper claws, as well as maybe I want to be able to adjust the size of that motor as well. So within your model browser, you do have this iLogic tab. If that iLogic tab is closed out, you can just go to your Manage tab, and then you can turn on that iLogic browser once again by just clicking iLogic browser. So there I have it. And before I actually get into the actual rules that are already in here, so this particular assembly, everything's already set up. I'm not going to kind of go through how to create those rules with our time constraints. It's just a complete iLogic assembly file, but I will kind of go over the different components that I want to be able to adjust. So before anyone ever thinks about going into your iLogic browser and creating the various rules, first thing you're going to want to do is figure out what components do you want to be able to adjust within your form. So I explicitly have the various parts up right now that I want to be able to manipulate within my form. So that being the material of this part, as well as the quantity of holes that go around here. So as most of you probably already know, every time that you create a dimension within your parts, you create what's called parameter names. And those parameter names start with, should be a D0 value, I believe, and then it just goes on to D1, D2, D3, and so on. When you are adding your various parameters to iLogic, it's very important to go into those parameters that you are going to be changing within your rule and give it an explicit name. So in this case, I know I want to change the quantity of holes that go around that base plate. So I change that to number of holes. There's some other fields within your parameters dialog box that you can kind of adjust here. maybe if I wanted to have a list, I could right click here and say make multi-value, and then I would let the user maybe only have the ability to change the number of holes to 2 or 4 or 6 or 8 or something like that. If it's not set to multi-value, then the user can enter as many quantity holes as they want. So this particular part, that's the only parameter that I have changed, number of holes. Material, I don't really have to do anything because there's a iLogic snippet that will allow me to dive into this piece part while I'm in my assembly file and be able to go into my material dropdown and adjust that material type, okay? So I'll just go on to this next part. So this particular part, I want to be able to change the length of this claw here, that vertical portion. So once again, go into your parameters, and then from there, if you scroll through your parameter name, you'll see that there is one already changed now. So this one probably was D3 at one point in time. That is the default model parameter. And that's really the only one that I want to be able to change within my assembly file. So I'll be able to dive down into this piece part and adjust this to whatever values that I want for the overall length. And then lastly, as far as the components, I have two completely separate motors. One is a different diameter here. This is just a smaller diameter, same overall length or width here. But then I also have this larger motor that might be, a higher horsepower or something like that. So just kind of wanted to point that out. So then I'll bring up this assembly file. So now from here, since I had already gone into my piece parts and I changed the parameter names to something more explicit, then it'll be much easier that once I get into my rules, I'll be able to automatically automate those various number of holes, as well as the length of the claw, as well as the replacing out of my motor. So as far as creating a rule within your iLogic browser here, I already have the two rules that I want, but just to kind of point out, you would just go into add rule here, and then you bring up this rule name dialog box, give it a name, click on OK, and then you'll start with a clean slate in your edit rule manager here, okay? So I'll go into this very first rule first. And this particular rule, what this rule is doing for you is it will be adjusting your quantity of holes in this copper colored base plate. So what this particular rule does is this parameter value is a a model parameter within your main assembly file. If I scroll down here a little ways, let's see here, should be user parameter, sorry. So if you go into user parameter, this is a parameter that was created within the assembly file. So I am telling Inventor that I want to dive down into the piece part. That piece part is the adapter plate. And there was a parameter that was changed to number of holes. So anytime that I change my quantity of holes within the assembly level, it will dive down into my piece part and will adjust that particular parameter, which is my quantity. Okay. And then down here, what this is doing, this would be taking my claw here, and I only have two different options. If I'm calling out for a short claw, then I want that claw to be 40 millimeters in length. If I want a larger claw, then it would be 60 millimeters in length. So you can do if, then, what if type of statements in the drop-down menu here, okay? So the way this is laid out right now, if, else, and end if, you only have two options that you can select from. If I may have added else if, then you can kind of have as many different iterations as you want, short, medium, long, extra long, and so on. But in this particular case, you're telling Inventor you only want to have two options there. And then this particular rule allows you to, whatever my material type is changed to within the assembly level. So if I were to go into my parameters dialog box here, I would see that there's a parameter, a user parameter that I had created called material. And then anytime that I change that material, it's going to dive down in my adapter plate, once again, which is this one. And I'll be able to change that to two different options, change it to maybe copper, change it to aluminum, okay? And then if I go into this second rule, this particular rule will allow me to physically remove one motor size and then bring in another motor size. So if you look in here, some of these rules may not make any sense whatsoever, but the nice thing about Inventor is you have your snippets here. So if I dive down into my folder for iLogic assembly and component snippets, you kind of scroll through here, you can see, let's go into add component here. So all I would really need to do is, let's just maybe add some space here. So I want to be able to go into a component and replace it out with a different size. So I could scroll down here. This is that motor. Right now it's set to the large one, but I could right click on that and just say capture current state. And here's just a little snippet. This is one way to do it. So right now it's just taking a little bit of time. And then I just added that exact same information that you just saw right up here, okay? So I'm just gonna cancel all of that for right now. I don't wanna mess up my rule here. And then you have this manage components snippet here. So what this snippet is doing, this portion of code at the very beginning as well as at the very end, is any component within my assembly that is not currently being used, by having that rule in there, that portion of code in there, I'm telling Inventor that I want to delete those components. So I'm using the large motor right now. I'm not using that smaller one. So Inventor will automatically delete it out if I'm not calling for it. Okay. All right. So the very next tab within your iLogic browser is the actual form. So I've already created a form here. If I just click on that, here's that dialog box, pretty straightforward dialog box. You can add the various tabs. I have a configurator tab as well as a gripper tab. So this gripper tab, I have it set up to be a slider bar. So I can change the overall length of my grippers. Those lengths are changing off of me driving a constraint within here. So there's a constraint going between that flat surface as well as the surface on this plate right here, okay? So if I change the one side, it's gonna symmetrically change the other side there. So within this form, I also have, you can see I have an image in there as well. You can bring in some pictures into your form. I have the quantity of holes down at the bottom that I wanna change. So I could grab that slider bar and drag it either direction. And you can limit the amount of holes that you want in here. So I could go in and I could edit the actual form and explicitly say, I only want to be able to select between 1, 3, 5, 7, 9 holes or whatever. But in this case, I'm going in increments of 1, right? So all the way up to 10. I want to change the material of that base plate. So here I mentioned I have copper as well as aluminum. So keep in mind that very first rule that I had showed you is set up to allow you to do that. And then you have the gripper claws, the length of the gripper claws, long ones versus short ones, okay? That second rule that I had showed where it's going to either delete out the large motor or the small motor. So depending on which one you're calling out for, it will remove the other one that you're not using. So let's see if I can go in here. So if you look down at the bottom, that's the small motor. Hit that drop down menu and select large. So now you can see it actually went in and it removed that motor. You're not actually suppressing a component. In some cases, in the older versions of Inventor, generally users would go into your iLogic and you'd either suppress out one motor in this case and then unsuppress the other motor. But now with each iteration of Inventor, now you have the ability to actually remove parts that you're not using in your model tree, kind of keep your model tree condensed, I guess. All right, so let's say maybe I wanna go into my form and I wanna edit my form. So I'll just right click on that tab and say edit form. So as you're creating that form, you have it up here on the side here, and then you have what's called your toolbox. So you can, if you wanna add a configurator or gripper tab or a third tab, you can just grab this and just drag it up here. And then as you're changing or making edits to your form, you're actually seeing it happen out here on the right, okay? So I'm going to right click on that and delete it. You can see it removed there. Here I have that picture, which is just an image there. Let's see here. Let's maybe I want to go into this holes here. So let's just click up in this holes, and then you come down to your property manager down here. And this is where you would specify, do you want it to be a slider, or maybe you have some other option here. You can just say just a simple text box, okay? So that's what that would look like. And I'd have the ability to enter whatever quantity of holes I want. All right, so this is basically the automating your assemblies without using the cloud, right? And then very briefly here, I'll go online here to a Forge example file, and there should be a link, I think, in the let's see here. You guys might have, if you look at the web address here up at the top, anybody can go to this site and you can just kind of play around with basically the cloud-based version here. So Autodesk has a couple different samples here that you can play around with, a wheel as well as a wrench. So this is basically just an online cloud. I could go in and change the size of my wheels, or maybe change the spokes. When you make a change, there's a flag that comes up here saying, hey, a change was made, you need to update it. So I can just click on update. Just it takes a little bit to just update it in this case. I'm just gonna you can make as many updates as you want at one time and then click update. But for, I guess, time constraints, I'm just gonna do one at a time, and it shouldn't take nearly as long. So right now I'm gonna be going from 5 spokes to 8 spokes here. Down at the bottom, you can also see there's some other tools as far as you're able to measure from point A to point B. There's some orbiting functions here. Kind of in the middle here, you can explode this wheel assembly in this case. At any time too, if anybody has any questions within the chat window there's a panel for questions, and at the end we'll answer those questions. All right, so here I just changed the rim to 8 spokes there. Maybe I wanted to change caliper finish or the actual wheel color. Let's say I like black wheels, so I can go in and change that. This one may not take as long because I'm just changing the color. We'll see here. And I'll just make this last change here, and then I'll kind of go through some of the different tools at the bottom here. Once this gets done as well, at the top, you can see that once you have configured your wheel assembly in this case, you'll be able to see a bill of material. And you can also export out that bill of material to a PDF format if you would like. And then you can also generate drawings as well. That's that tab right next to the bill of material tab. And then once I go through the sample here, then I'll give it over to Corey, and he'll kind of go through the meat and potatoes of how the cloud-based automation works in Forge here. And you can see there's that wheel. As I mentioned, you can go into the bill of material tab, and this is something that you can either allow or not allow for customers. They can go onto your website, and just like what we saw here, go onto your website, and there can be a spot where they can configure their wheel assembly, or maybe you have a dock assembly or whatever your company makes, and they can go in and configure it to their liking. So I made a change to the quantity of the spokes as well as the color of the wheel. So once this is done generating the drawings, then in this case, this particular forge example, there was 3 drawings that were created. One was just the main wheel assembly, and then there's a couple other drawings, which you can see as a stud disc is what it says. So creates a nice little drawing here. You can see it has the right quantity of spokes. I'm just going to go to the second drawing. I'm not going to go on to the other one. I'm getting short on time here. Hopefully give Corey enough time to go through his portion. All right, so there's that drawing, just the stud disc. As I mentioned, measuring from point A to point B here. Okay. Delete measuring tool. Could explode it if you wanted to. There's a little slider bar here to, in this case, explode that wheel out. So this particular cloud-based configurator, this is kind of feeding off of iLogic. You can actually bring in your iLogic model. I could bring in that gripper into Autodesk Forge, and however you had set up your form within the iLogic assembly is kind of how you would see it within your Autodesk Forge platform here. So I guess with that, I'll give it over to you, Corey, and hopefully I gave you enough time for your portion. Thank you. You're on mute, Corey, too.
I was on double mute. All right. Everybody hear me okay?
Yeah, I certainly can.
All right. We will jump right into this. Thank you, Jerry, for going over the iLogic rules and the configurator for us. So if we have some function that we've built, now we want to automate it further, maybe let's make 1,000 of those wheel models. How do we do that? Well, Autodesk is kind enough to provide us with a few different public interfaces, so a programmer can write functional code for their products. These are called APIs, stands for Application Programming Interface, and these are pretty much libraries of defined functions that you can call, and the programs know how to respond to them. So I'll go through the 3 of them. First, there's the AutoCAD API, the Inventor API, and the Vault API. For AutoCAD, let's get this out of here. Put you down here. There's the option to have a plugin that gets installed to your AutoCAD program, so you can kind of run not iLogic, but you can run add-in functions kind of the same way through the ribbon, or it can be through an externally called program that can manage its own interface. It can tie into a running instance of AutoCAD, and opportunities for this application. If you wanted to, let's say you have a block on your drawing, it has a little info about the drawing. You could use the API to change those values. You could go through a batch of prints, print them all out to PDF, save them somewhere, a network drive or something. You could add stamping info to the top of the drawing. There's all kinds of things you can do, and then this little bit on the bottom here is just an example of how the syntax or the programming lingo works for it. And next we'd have the Inventor API, which kind of functions the same. It can be an add-in, which is not too unlike an AutoCAD plugin. It's just the naming for an Inventor version of it, or this could also tie into an external program that runs its own instance of Inventor, or ties into one that a user has open. And then this can do similar things where you can change the iProperties. So maybe you have some input values for a model, and you want to run some of Jerry's iLogic on it, but you need those input values. Well, you could use this Inventor API to pre-fill those, then run the rule, and then pull them back out. So this helps if you have your configurator and you need to get those new values, and you have your car, it can be an i4 V6 13B Wankel rotary with your 17 to 21 inch wheels and 3 kinds of interiors. This is how you would tell it, we want the V4 or the i4 red with 18-inch wheels. And lastly, there's, oh, I gotta go over this first. There's a few different ways to access this API. There's standard Inventor, which everyone's familiar with, your regular Inventor program. Inventor read-only, which can do limited scope of what regular Inventor can. It's kind of in the name read-only. You can look at a drawing, you can get values, you can't change anything. Inventor View is specifically just for looking at the models. It doesn't open a full instance of Inventor, and that gets when that is installed, it installs Inventor Apprentice, which also is installed from regular Inventor. And that is a UI-free kind of trimmed down version. It's a lot like Inventor read-only, except there's no visual side to it. And then Vault has its own Inventor that it uses to process called Inventor Server. And that is specific to Vault. There's no standalone for it. You have to have a Vault job processor to use Inventor Server. So each one of these, you could use it if you have a different capability you need done. So if you actually have to change some values in a drawing, you would need to use something a little higher than Inventor Apprentice, whereas if you're just reading values out of a drawing or an assembly and doing something with that info, you would just need Inventor Apprentice to pull that data out since you're not changing anything. No matter which one you use, they're all going to be using the same AI code. So there's some portability between them all. If you have code that works in one, as long as it's not doing something beyond its capabilities, the code should work with any of the other ones. And lastly, we have the Vault API, which lets a program connect to Vault server as a sort of pseudo Vault client. That includes automated programs as well. So with no UI, it can check out files, it can do life cycle state transitions, you can do revisions, you can download files from Vault, you can upload files to Vault. And this is good if you have giant batch operations and you don't want to go and click everything, or if you have an automated process that maybe needs to check out a bunch of drawings, get some data from them, and then put them back in. So the two ways that we can use these APIs are the cloud-based Forge, which offers these APIs through Autodesk's cloud services to run these. So it's like running Inventor on someone else's computer or running AutoCAD on someone else's computer. There's not currently anything set up for Vault, as far as I'm aware, but you can use code that interacts with Forge to interact with Vault too. You can combine any of these things however you need to. It's just a matter of writing that automation. So the Forge architecture is like this. In Jerry's case, the app itself is you're accessing a hosted C# app that's bringing you the front end, and then all of the background stuff where you're changing configurations, generating drawings and bombs, that's what's being done on Forge using the Inventor API. So a client will log in with their account. Now they have access to these Forge functions that'll get sent through. So when they click on something, it's sending this HTTP request out to Forge. Forge is picking it up and going, okay, they're using this command, so we're going to use this app bundle that's been loaded, and we're going to return this output to them. And using these calls can cost cloud credits. It kind of depends which one you use, and I think the rate is something like, it's like 4 credits per like, what is it, 10 minutes of of use of AutoCAD and 6 credits per 10 minutes of Inventor processing time. So it charges you based on how much you're using it. So if something takes just a couple seconds, it's only going to charge you fractions of a cent. There's documentation and tutorials for most of the basics of Forge so that you could get your simple app set up. It kind of involves a fair bit of setup because you have to write an app bundle, you have to upload it to Forge, you have to define your parameters, so what you're going to send in and what's going to come out of it. But once that's all done, it's accessed pretty easily with just HTTP requests. So you could have these requests come from a website, someone clicked on something and it sends a request out, brings back Forge info. You could have an automated list where, okay, I've got all my parameters, now just go through and send bing bing one HTTP request for all of them and bring back your info. iLogic can be run in Forge without needing to upload an app bundle. So let's say you're not the best at C# or VB.NET programming, but you have some iLogic rules you want to run. There are ways to upload your file with the iLogic rule and just have it run the rule and return it back, and no special app bundles are needed. The other option is using an on-premise worker machine of sorts to do the automation work for you. And the options there would be using a headless or invisible Inventor or AutoCAD instance, which is going to be running the full software on a machine. It's just doing it in the background with no user interaction. There's Vault automation, so you could have a scheduled task that checks the database for any new files in a folder somewhere, and if it finds something new, it goes on Vault, updates any info it needs to, bumps up a revision. The Vault job processor with Inventor server. This one's kind of special because it sort of does all of the queuing and management for you. The Vault server has its own Vault queue that the job processors will pull off of and run the job that can use the Inventor API. But all three of these are going to need some kind of way to control the automation. So for headless Inventor, it creates a full instance of Inventor, Inventor Apprentice, any one of those ones I listed earlier in AutoCAD. These do use a license while the instance is open. So if you use really careful management of when you're accessing these pieces, you can get a lot done without needing to use a lot of time on the license. So you're not squatting on it so much. If license management is a big issue for you. One of the downsides here is that this machine can only respond to one request at a time. You can't, if you get 10 that come in at once, it can only do 1, then 2, then 3, then 4. Just because of the license limitations, so you can't run 100 different things off of one instance of AutoCAD. The Vault automation uses it's an object that Autodesk made so that you can mimic a Vault client connection, and it's called Vault Web Services. You just log into a Vault server as a setup user. You could make your own user that has special permissions, and this is just an automation user. No human will ever log in as it, and it only uses a Vault license when it's doing write operations. So like I said before, you could go through and read through a bunch of assemblies, get the data you need. And this won't use the Vault license, but if you're going in and changing anything, then this will. The job processor through Vault, this uses job handlers that are written in C# or VB.NET, and these use the Vault and Inventor API to do whatever unit of work you want to call that job. The Vault client installs the job processor. It's a separate program from Vault client. And when it's running, it uses a client license. So it's sort of a passive thing. You start it up and it just sits there and it checks the queue for jobs. And if there's a job that matches its job handler types, it'll pull it off the queue and start running it. And this uses Inventor server in the background, so it never interacts with the user, or if there is a user on the computer. It only changes things when it's running. So otherwise this will just be blank and it'll say idle. It finds a job, picks it up, processing. Here's C. Andersen, custom job. And so in order to get these jobs to the queue, you need some way to add them. And we'll do that through Vault web services as well. If you see in my code sample here, it's pretty simple. I log into the Vault server. I add my parameter. I want to run this rule, and then submit the job and sign out. And once that's done, this job will make it to the queue, and the job processors that are listening on that queue will start trying to process it. Here's an example of the queue, and this will be filled with however many jobs you put in there. You can configure it to check every 10 minutes for a job processor. You can check every minute, every 5 minutes. You can have more than one job processor grabbing jobs off of the same queue. You can hook them up to different ones if you'd like. There's no real limit to how many can be connected, so it's sort of scalable. It's just that you'd have to. It's hard to explain it. You'd have to have sort of an idle user in order to do this. You wouldn't necessarily want to have your job processor running while a client's doing something on their computer, but let's say overnight their computer's just sitting there idle. You could have it turn the job processor on and start doing some work. So this is a diagram of how the job processor is doing all of this. So I've got these numbered here. A job trigger script. This is just something that's going to add a job to the list. This could be a scheduled task. It could be grabbing something from a message queue. It could be maybe someone is on a website and has clicked something to add this job. Well, it's gonna get whatever it needs for its parameters, however you want to set that up. If they're being directly added in, if you want to read a JSON file somewhere, if they're being sent directly from the user, it uses these parameters to add the job to the job queue. The worker machine is going to get that job off, checks to make sure if the job's a valid type it can run. You can fill in your values for the rule, run the rule, get whatever values you need out. Maybe you want the whole assembly file to come back after it's done. It can do any number of things because it has the full power of Inventor. There's no limitations for what the job processor's Inventor can do. It can do just about as much as the full graphical user interface Inventor. So in summary, there's options for both, and no matter which way you cut it, you're gonna need some kind of way to control the automation if it's not user kicked off. So the options, you got job queuing with the job processor. You could use a message queue. You could pull data off of a database and respond to it. You could build a web API that handles all of it and sorts out where info needs to go as kind of like a central brain of the automation. Autodesk's getting rid of the multi-user license. So any self-hosted automation users will need their own licenses. They can't just pull one of the free ones as needed. That kind of creates a hiccup. Their philosophy was you're no longer an ID, you're a human, except when we're doing automation. We are using IDs and not humans, but it's just something we'll have to deal with. The benefit though is that the actual API logic is transferable between options. So if you have some iLogic rule that you really like, it runs well, you can start it, your automation, with some local machine just to test it out, get it all started, and then later you could go and put that API code up on a Forge app bundle and pretty much run it the same way. It's just instead of calling a Marshall to Inventor, you would just do your Forge API calls. So it's nice that you could switch between the two if you needed to. And my diagram at the bottom here kind of shows that they're both doing the same thing. This Vault API library, this is the same way it connects to Vault Server here. And Inventor API, we just switched that out with Forge doing the work. So the questions you'd want to ask are, first off, scalability. Running an Inventor instance on a self-hosted machine, you have one worker machine you can use, and that one worker machine only. You can add one, and now you have two, but what if you need to add 100 real quick? What if you get 1,000 requests? Forge is definitely going to have the upper hand as far as scalability goes, because any request you make, it has resources available to process it. You're not limited by a physical number of machines or Vault clients running job processors. The request response speed, this kind of depends on what you're doing. Some functions on Forge seem to take a little bit longer. Some on job processors seem to take a little bit longer. The Cadillac, of course, is just using full Inventor to run these, but that's not always an option. So in this case, Forge is probably going to be better at response, unless the internet's down, of course, in which case the self-hosted may or may not perform better for you, but those are the limitations of the cloud, is needing that always on internet connection. Ease of maintenance, they're both kind of equal in this regard. Forge is a little different to set up if you're not used to using cloud services. It's not too different than how Azure or Amazon Web Services work. You have storage buckets, you have your API endpoints, and you put them all together. And once you have that done, they're pretty easy to call through HTTP. And then, like I said before, between the two, you can port the code for Inventor itself or AutoCAD itself between the two. So the maintenance there's kind of even, which leads into ease of development as well. It depends what your weakest area is, I guess. If you don't want to set up a whole web API to control this, you don't have to. You could do something already set up using some of Autodesk's tutorials. You could use the job processor. That one's really easy to get set up. Once it's going, it's like a set it and forget it kind of thing. Once the job processor is set up, it's all self-contained. And again, the C# between them is going to be pretty similar. So the ease of development between the two is kind of the same. It's just Forge has more of a learning curve getting set up. Licensing considerations. Anything done on Forge that has a cost is based on the amount of time it takes. So you're never really wasting any of your your spending on Forge. Everything you spend is going towards something, whereas you might have a job processor squatting on a license doing nothing half the time. And the way that Autodesk is changing those licenses away from the multi-user to the subscription single user, licenses might be more of an issue for you if you have a lot that you're going to need to be using. So maybe Forge would be better, since you don't have to manage all those yourself. And then logistics comes into play, as it always does. Licenses cost money, cloud credits cost money, development time takes money. It just comes down to asking some questions. Is the process time critical? How long does it take? What's the downtime? What's the frequency this process is going to be running? How do you handle surges? How do you respond to outages? These are all things you're going to have to deal with, again, regardless of if you're running cloud or not. So I think Autodesk is trying to push people more toward the cloud environment as well. So as the future goes on, I think we're going to see less and less that we can do with self-hosted machines, since they're trying to get us over to Forge. All right, is there any questions? That's the end of my presentation. We can take any if anyone's got one.
Yeah, there's one question in the box, directed at Jerry. Do we offer training on iLogic?
Yeah, absolutely we do. Pretty much at least, I'd say at the least once a month. If you guys, any of you guys go to our website, there's a calendar for the various classes that we offer. And in most cases, Eric Miller kind of sets up the classes, and he does his best to, try to make everybody happy with assortment of different classes. One of them being the iLogic one, at least once a month, I believe, as well as some of our more common ones. The Inventor intro class is a common one that myself as well as Eric do every single month, as well as maybe some of the not as frequent classes like sheet metal or advanced part modeling, advanced assembly modeling. I also do AutoCAD classes as well. So if anybody wants to do, I call it expensive Etch-a-Sketch, but I do either a 3-day AutoCAD class, which is the essentials, or I do a AutoCAD fundamentals class, which is a full 5-day class. So take a look at our website calendar, and if you ever see iLogic in the calendar, please get set up with it, and hopefully you can start making some intelligent models out of your designs. So thank you.
Absolutely. Thank you, Jerry. It looks like that was the only question that we had. So was there anything else from either of you two?
I think I'm definitely good on my end. So
Yeah, I said more than I had written down.
Okay, great. Well, then I'll wrap it up here. Thank you everyone for attending this session of Applied Day. Have a great rest of your day.
yeah, thanks everyone.